Hey everyone, thanks for having me. We're going to pivot a little bit here and talk about something that I don't think has been addressed yet today, which is bad impacts by wind turbine facilities. And this has some implications given the recent uplisting of the migratory bats in Ontario. And yeah, this is a collaborative approach with some of our colleagues at Natural Resource Solutions. And we'll be presenting the results comparing our bat activity using acoustic detectors to the fatality rates at wind turbines across Canada. Bit of background. Yeah, as we mentioned, we've got our migratory bats now listed as endangered provincially and federally. Traditionally, we've used acoustic bat data to inform on the risk of bat fatalities prior to construction of wind turbine facilities. Research tells us that operational acoustics at the base of turbines is a good predictor of fatalities at those same turbines. But the link between pre-construction acoustics taken before the construction of the turbines is a bit more controversial, and the link is a bit weaker. So using the data presented here, we were looking at those two relationships to sort of see whether these assumptions that we've been thinking about determining risk actually holds up. Those are actually bat photos from colleagues at NRSI, and those are the three migratory bats in Ontario. We took fatality data. Well, let's start off with acoustics actually. So our acoustic data was taken from a variety of wind projects across Canada, 12 wind projects across Alberta and Ontario, totaling about 107 bat acoustic stations. In both provinces, these acoustic stations were located in the southern parts of the province, and we focused this research specifically on the three migratory species illustrated on the chart. For the acoustics data, we positioned the microphones at the base of the turbines, at least for the operational data acoustics when the turbines were actually there. For the pre-construction acoustics, these detectors were often placed at presumed locations of turbines, so not necessarily where the actual construction took place. Data was collected from May of October to correspond with the full seasonal timing of potential migratory bat activity. And it was then auto-classified in two different ways. So a lot of the pre-construction data that we used only classified up to the migratory and non-migratory division. So we grouped all migratory bats together and reported it as such. For the operational acoustics, we more reliably identified it to the actual species, so the three migratory species in question. And then we standardized the actual bat activity by dividing the bat pass rates by the number of detector nights to address any gaps in the data. At the operational data collection, we also collected fatalities of these bats. And so we used the particular agency protocols for bat fatality collection. And there's a little bit of variation in the Alberta and Ontario procedure, but they're generally the same. It was all just reported as a group, so all migratory species all at once. Unsurprisingly, we get this really dispersed data and a non-significant poor relationship. Just going back a bit, we did have 26 paired acoustic detectors in this case, 13 in Alberta and 13 in Ontario. And finally, in that third relationship, we were comparing pre-construction acoustics to operational acoustics, and there was a very strong relationship, so about 85% variance extent, or if you want to call it a correlation with that. So in this particular case, because we were limited by the migratory grouping for the pre-construction acoustics, we did the same thing for the operational acoustics. So what does that all mean? In summary, what we see is that if you divide your bat acoustic data collection by species, it shows a fairly good relationship with the operational fatalities that you're expected to see. So more silver bat activity at the base of the turbine generally leads to more silver bat mortality at that turbine. Makes sense. Pre-construction acoustics had a bad relationship with operational fatalities, and in multiple ways you can explain that. First of all, probably the location of the detectors had nothing or little to do with the actual placement of the turbines. Generally, it's done before the layout of the turbines is finalized. And the construction of turbines has also been hypothesized to impact the behavior of bats. So it could increase bat activity because it lures them in, they're curious about it, or it can also detract them in various ways. But also, remember in the pre-construction, we grouped all the migratory species together, but clearly we saw species-specific effects. So grouping the 3 migratory bats, which clearly have different behaviors, doesn't make much sense when we're talking about acoustics and fatality data. But, and the final point on this slide shows this, is that if that relationship between pre-construction and operational migratory bat activity is very strong, then if we can just commit to identifying pre-construction acoustic activity to species, then perhaps we can have a better picture, a better idea of the mortality risk per migratory species. And the implications of this, particularly with the recent listing of these species, is important because the regulatory agencies are put specific requirements on these wind facilities, and they're going to be placing a lot of emphasis on acoustic data to inform the mitigation approach. So we want this data collection to be as effective and as biologically informed as possible. And some other thoughts, some other takeaways. Clearly, ground-based detector data is moderately effective at predicting mortality risk at the cell of the turbine. Generally, it's recommended that if you want less data, you collect that acoustic data from the cell, but that might not necessarily be required. And we can use these operational acoustics to guide our smart curtailment approaches. So limiting curtailment and maximizing production based on these turbine-specific acoustic rates. And of course, as I mentioned before, we have to get better at identifying 2 species, because clearly these species have different behaviors, different interactions, different frequencies of occurrence on the landscape, and that has implications for the risk. Thanks.
Thank you so much, Dorian. Sorry guys, no time for questions on this one. Just going to get to the next presentation, organized, so 1 minute.
Never seen him.